So in this video lecture, we are going to solve a question regarding the design tension capacity of a butt weld. So let's write the question. A plate having thickness of 14 mm and width 150 mm is joined by another plate of thickness 12 mm and width 200 mm by a single V butt weld. Yield stress for weld material is 260 MPa and yield stress for plate is 250 MPa. What is axial load carrying capacity of butt weld? So the question is simple, in which we are given some data regarding the thickness of two plates. One plate dimension is, it has thickness of 14 mm and width of 150 mm, while the second plate has thickness and width as 12 mm and 200 mm. So let's try to draw how these plates would look like. So this is our one plate and this is 150 mm width, while the second plate is a little bit more wide of thickness 200 mm. Okay, and now we have some weld in between, so we can denote a weld like this. This is the weld, this is the butt weld. So how we will find out is, our hint in the question is this: we are using a single V butt weld. So we know that the penetration is going to be partial, and for the partial penetration, the thickness of weld is taken as 5 by T thickness of plate. And by the thickness of plate, T means thickness of thinner plate. So T plate is thinner plate thickness. So the thinner plate has the dimensions of 12 mm, as it's visible in the question, because the one thickness is 14 mm and one thickness is 12 mm. Thickness of T plate will take as 12 mm. So what will be the thickness of weld? It will be 5 by 8 into 12. So the result would be 7.5 mm. Okay, so what is going to be the area of weld? It is going to be thickness of weld into effective thickness, effective length. So the effective length would be the smaller of the two width, that is 150 and 200. So the smaller will be 150 mm. So we are going to use like 7.5 into 150. So the area of butt weld would be 1125 mm square. Okay, and the design tension capacity formula is governed by yielding. So the formula would look like this. So what is going to be Fy? Fy is going to be minimum of weld capacity for the parent metal. Parent metal yield strength is 250 Newton per mm square and weld is 260 Newton per mm square. So it's going to be governed by the parent metal. Okay, so we are going to use the parent metal yield strength 250 upon what is going to be MW and gamma MW. This is partial factor of safety, which we will take as 1.254 choke welding and 1.50 for field welding. Since in the question it is not given that the welding is choke or field welding, we usually take it as choke weld. We can also write that assuming it is as a choke weld, but still it's normal thing to assume it like a choke weld if not given in the question. So 1.25 into area of weld is 1125. The answer we will get is in Newton. So the answer comes around 225,000 Newton, or we can say that it's 225 kilonewton. So this is our answer, final answer. Well, thank you for watching this video. Have a good day.